Hi everyone, we are Group 3, Aceron, Juby Diaz, Edson D, Kabahar, Lastimado, and Novador. And we have been waiting for this opportunity for our group to present to you our presentation and have a discussion with the class. And our topic today is about production and cost analysis, part 1. But first, we have to understand what a product function is. So, a product function combines a firm's physical capital stock, labor, raw materials, and technology in order to produce an output. So, technology is the knowledge that a firm possesses together with the managerial skills. By input, we mean any of the factors of production, such as physical capital, labor, or raw materials. So the marginal product of an input is the extra output obtained if extra input is used. In the next slide, there will be an illustration that shows the output produced by a firm given its inputs. So the link between the inputs and the output is the production function characterizes the output of a firm given in the input it uses. So there are two important properties of production function, and these are positive marginal product of an input and diminishing marginal product of an input. The first property is the positive marginal product of an input. The first property asserts that the additional output will be obtained from additional units of an input, like adding some another machine, another worker, or some more fuel, and so on and so forth. That increases the output of a firm. So a positive marginal product does not necessarily mean that there is a extra out that the extra output is profitable. It might be that the cost of the extra input is high relative to the value of the additional output obtained. So the second property of production function is the diminishing marginal product of an input. So the second property explains how the marginal product of an input changes as we increase the amount of that input, keeping the quantities of other inputs fixed. So an additional unit of an input will usually increase output more when there is a small amount of an input being used. So next, this slide shows the two properties of the production function, which is the positive and diminishing marginal product of labor. So this illustration states that as more labor is added, output increases. Then there is a positive marginal product of the labor. But when there is an extra output obtained from adding labor, wherein it is greater when the labor input is low, then there is a diminishing marginal product of a labor. So next slide is we have to talk about the three measure of productivity. So the three measure of productivity is total product, marginal product, and average. First, what is productivity? So productivity measures how efficiently production inputs such as labor and capital are being used in an economy to produce a given level of output. First measure of productivity is the total product. So the total product as the total volume or amount of final product produced by a firm using given inputs in a given period of time. Second is the marginal product is an additional output produced as a result of employing an additional unit of the variable factor input. Thus, the marginal product is the addition to the total product when an extra factor input is used. Lastly is the average product. So the average product is the output per unit of factory inputs or the average of the total product per unit of input and can be calculated by dividing the total product by the inputs. In the next slide, we can see the relationship between these three measures of productivity. So the relationship between marginal product and total product is when only one variable factor input is allowed to increase and all other inputs are kept constant. So first, when the marginal product increases, then the total product also increases at an increasing rate. When the marginal product declines but it remains positive, then the total product is increasing, but at the same time having a decreasing rate. So when the marginal product is declining and it is negative, then the total product declines. Next, when the marginal product becomes zero, then total product reaches its maximum. The relationship between the average product and marginal product is when the average product is rising, then of course the marginal product lies above the average product. Next is when average product is declining, then the marginal product lies below the average product. And lastly, when the maximum of average product, at the maximum of average product, the marginal and average product is equal to each other. Let me now turn you over to Ms. Juby Diaz for the role of manager in the production process. Thank you.
The role of manager in the production process. So the manager is concerned in the production planning of the enterprise. So the production planning is concerned with thinking in advance what product to be produced, how is it to be produced, and by what time should it be produced. So the managers are concerned with deciding about the production targets to be achieved by keeping in view the sales forecast. Next is the production control. Managers are concerned with successful implementation of production planning. The manager should also ensure that there is a continuous production and a minimization of waste is observed. Next is the quality control. The managers are concerned in maintaining the quality of the product. So the manager should be concerned with controlling the negative variables which could affect the ultimate quality of the product. Next is the method analysis. The production manager should have knowledge or background of all the methods they have used in the production by analyzing them and then select the best alternative in minimizing the cost of the production and the improvement of the productivity. Next is the inventory control. Manager should exercise proper control over the inventory, such as determining the economic order size, the maximum, minimum, average, and danger levels of materials in order to avoid the overstocking and or understocking of materials. Having inventory control also helps in minimizing the wasted materials. Next is plant layout. Managers should be familiar with the internal setup of an enterprise and ensure that the enterprise has a proper arrangement of materials and proper use of their available resources. The manager should see to it that there is a maximum and effective utilization of resources available at the minimum operating cost. Lastly is the work measurement. Managers should measure if the workers or employees are performing positively or negatively in the workplace. Time and motion studies techniques can be used for work measurement. So if a worker works below the level fixed by the work measurement techniques, his performance must be improved through positive incentives such as promotion, work benefits, or raise in the salary, or through negative incentives like demoting to a lower work level or firing them in the company. So there are three algebraic measures of productivity: total product, marginal product, and the average product. Total product is the overall output that results from employing a specific quantity of resources in a given production system. The total product concept is used to investigate the relation between output and variation in only one input in a production function. So it can be computed as TR is equals to AR times Q, wherein TR is the total revenue AR is the average revenue, and Q is the output. Given the total product function of an input, both the marginal and average products can be easily derived. So the marginal product of a factor is the change in output associated with a 1 unit change in the factor input, holding all the other inputs constant. So it can be expressed as MP sub x is equals to change of Q over change of x, where change of Q is the output resulting from 1 unit change, which is the change of x in the variable factor. So this expression assumes that the quantity of the other input, which is y, remains unchanged. Average product is the total product divided by units of inputs employed. So the higher the average product, the more productive a factor of production is. It can be expressed by dividing the total products over the unit of variable factor input, or as you can see in the screen, the formula is AP sub x is equals to Q over x. To give an illustration about the relationship between the three algebraic measures, as discussed by Ms. Aceron a while ago, here is a illustration. So, for the relationship between the marginal and the total product, the law of variable proportion is used to explain the relationship. It states that when only one variable factor input is allowed to increase and all the other inputs are constant, the following can be observed. So as you can see in the graph, as the marginal product increases, the total product also increases at an increasing rate. When the marginal product decreases, the total product increases at a decreasing rate. And then when the marginal product is negative, the total production declines. Next is the relationship between the average product and the marginal product. The marginal product and average product initially increase and then decrease due to the operation of the law of diminishing marginal returns. So when the marginal product is higher than the average product increases. So as seen in the graph, as long as the marginal product is greater than the average product rises until the third unit of variable factor. When the marginal product becomes less than the average product declines, as you can see or as you can observe in the fourth unit of variable factor. And then after that, in the succeeding unit of variable factor, both the marginal product and then the average product declines. But as you can see, the marginal product curve is steeper because the marginal product falls faster compared to the average product. And although they are both declining, the average product remains in the positive line while the marginal product reaches the negative line. So for the law of diminishing returns to a factor, it will be discussed by Mr. Edson D.
The law of diminishing returns to a factor. This is also known as the law of diminishing marginal returns or principle of diminishing marginal productivity. It is stated that in the short run, when variable factors of production are added to a stock of fixed factors of production, total or marginal product will initially rise and then fall. So what we are talking about here is that as the quantity of a variable input increases, the resulting rate of output increase eventually diminishes. It goes down. So input combination choice. The concept of factor productivity can be more fully explored using the isoquant analysis. So this explicitly recognizes the potential variability of both factors in a 2-input and 1-output production system. So the term isoquant is derived from iso meaning equal and quant from quantity. An isoquant shows the different combinations of capital and labor that give the same output. For input factor substitution, isoquant shapes reveal a great deal about the substitutability of input factors, as you can see in the table. So here is the marginal rate of technical substitution, or also known as MRTS. So this is the amount of one input factor that must be substituted for 1 unit of another input factor to maintain a constant level of output. Here below is the general algebraic expression. So next we have the rational limits of input substitution. So it is irrational for a firm to combine resources in such a way that the marginal product of any input is negative, because this implies that output could be increased by using less of that resource. So the marginal revenue, product, and optimal employment will be done by Ms. Charlene Cabahar.
So now we will discuss about marginal revenue product and optimal employment. So marginal revenue product is the economic value of a marginal unit of an input factor. It is the additional amount of revenue earned by a firm after employing an additional unit of labor. So it also calculates how many employees they add or hire before losing money. It analyzes the effect of a variable input like labor that follows the law of diminishing returns, in which, as the number of variable input increases, revenue generated by each one decreases. So in the equation, it shows that the MRPX is equivalent to total revenue divided by an input, and then broken down to quantity divided by an input times total revenue, which is divided by the quantity and can be translated into marginal product times marginal revenue. So for example, if an addition of one worker generates 2 incremental units of a product that can be sold for 5 pesos each, in getting the MRP, we multiply the marginal product of 2 units times the marginal revenue of 5 pesos, in which we get the marginal revenue product of 10 pesos. So now we have the marginal revenue exceeds marginal cost that results to profits increases. So next is that when marginal revenue exceeds marginal cost, profit increases. This means that as a company makes product decisions, the profit will increase as long as the marginal revenue generated by the input exceeds the marginal cost of employment, in which conversely, marginal revenue product less than the cost of employment will result to marginal profit as negative, and the firm would reduce usage. So in the formula, marginal cost of production is equal to total cost divided by output, or can be simply expressed as price of labor divided by the marginal product of labor, which is the units of output gained by the employment of added unit of labor, which provided the measure of marginal cost of production. So while at the profit maximizing output level, it must be remembered that the marginal revenue must equal to marginal cost. So from the previous formula, we can substitute marginal revenue to the marginal cost, resulting to this expression. Marginal revenue equals to product price of labor divided by the marginal product of labor. So next, we have another example. So if the price of input X in the production system is 12 pesos, how many units will the firm use? So from the table, the 3 units of X will be applied. This is because the value gained by adding the first 3 units exceeds the marginal cost, which is again the 12 pesos. So when 3 units of X are employed, the third unit causes total revenues to rise by 15 pesos while costing only 12 pesos. On the margin, when the firm employs the third unit of X, there's an increased total profit by 3 pesos, which we get by simply deducting marginal revenue, 15 pesos, by the marginal cost, 12 pesos. For the fourth unit of X, it will not be employed because the value of its marginal product is 10 pesos, that is less than the cost of employment, which was 12 pesos. Profit would then decline by 2 pesos, which is also the same for the fifth unit, where profit would also decline by 7 pesos. So next is optimal employment. So in profit maximization, it must be remembered that marginal revenue product is equal to the price or the marginal cost for every input. This is because it is not efficient for a firm to pay its workers more than it will earn in revenues from their labor. So, if a marginal revenue product exceeds the cost of an input, profits could be increased by employing additional units. When the marginal cost of an input factor is greater than its marginal revenue product, profit would increase by reducing employment. So there is optical employment when all firms employ resources as to equate each input's marginal revenue product and marginal cost. So in the formula, we have the price of labor equals to the marginal revenue quantity times the marginal product of labor. So lastly, we'll be talking about the marginal revenue product of labor. It is the change in revenue that results from employing an additional unit of labor, holding all other inputs constant. So from the formula earlier of profit maximization, it can also be expressed as the price of labor equals to marginal revenue quantity times marginal product of labor, or simply as price of labor equals to marginal revenue product of labor. So why is MRP important? It is crucial for understanding the wage rates in the market. It only makes sense to employ an additional worker at 15 pesos per hour if the worker's MRP is greater than 15 pesos per hour. So if the additional worker cannot generate an extra 15 pesos per hour in revenue, then the company loses money. That would be all, and now I'll hand you over to Vanessa Lastimado.
In the next part, we have the optimal combination of multiple inputs. Optimal input proportions can be found graphically for a two-input single-output system by adding an isocost curve or budget line in which it is a line of constant cost to the diagram of production isoquants, and each point on the isocost curve represents a combination of inputs, let's say for example, X and Y whose cost equals a constant expenditure. So next slide please. A budget line is merely a statement of the various combinations of inputs that can be purchased for a given dollar amount. So for example, the various combinations of X and Y that can be purchased for a fixed budget, let's say B, are given by the expression of B is equals to P sub X times X plus P sub Y times Y. So solving this expression for Y so that it can be graphed as in figure 7.8 results in Y is equals to P over P sub Y minus P sub X over P sub YX. So the first given expression is the y-axis intercept of the isocost curve, and it indicates the quantity of input Y that can be purchased with a given expenditure, assuming 0 units of input X are bought. So the slope of a budget line and measures relative input prices. A change in the budget level B leads to a parallel shift in the budget line, and it changes in input prices alter the slope of the budget line. So as you can see in figure 7.8, the budget line is illustrated and constructed in the following manner. Let P of X is equals to $500 and $250, the prices of X and Y. So for a given budget, let's say B sub 1 is equals to $1,000, the firm can purchase 4 units of Y is equals to $1,000 divided by $250 and no units of X, or 2 units of X is equals to $1,000 divided by $500 and none of Y. So these two quantities represents the X and Y intercepts of a budget line, and a straight line connecting them identifies all combinations of X and Y that $1,000 can purchase. So next slide please. Connecting points of tangency between isoquants and budget line, an expansion path is identified that depicts optimal input combinations as the scale of production expands. So at the point of optimal input combination, isocost and the isoquant curves are tangent and have equal slope. So the slope of an isocost curve equals negative P sub X over P sub Y, and the slope of an isoquant curve equals the marginal rate of technical substitution of one input factor for another when the quantity of production is held constant. So therefore, for optimal input combinations, the ratio of input prices must equal the ratio of input marginal products, and the expression would be P sub x over P sub y equals MP sub x over MP sub y. So alternatively, marginal product to price ratio must equal for each input, such as MP sub x over P sub x is equals to MP sub x over P sub x. So for optimal input proportions are employed when an additional dollar spent on any input yields the same increase in output. So any input combination violating this rule is suboptimal because a change in input proportions could result in the same quantity of output at lower costs. Next slide, please. Optimal levels of multiple input. Cost minimization requires only that the ratios of marginal product to price be equal for all inputs. Alternatively, cost minimization dictates that inputs be combined in optimal proportions for a given or target level of output. Next slide, please. Profit maximization requires that a firm employ optimal input proportions and produce an optimal quantity of output. Cost minimization and optimal input proportions are necessary but not sufficient for profit maximization. Additionally, profit maximization dictates that the firm employ all inputs up to the point where MC sub Q equals MR sub Q. Also, profit maximization requires for each and every input that P sub x over MP sub x is equals MR sub Q, and P sub y over MP sub y is equals MR sub Q. When rearranging, it produces P sub x is equals to MP sub x times MR sub Q equals MRP sub x, and P sub y is equals to MP sub y times MR sub Q is equals to MRP sub y. So profits are maximized when inputs are employed so that prices equals marginal revenue product for each input. Next slide. The difference between cost minimization and profit maximization is that cost minimization requires efficient resource use as reflected by optimal input proportions, while on the other hand, profit maximization requires efficient resource use and production of an optimal level of output as made possible by the optimal employment of all inputs. Now I will hand you over to Ms. Lavador for the next slide.
Returns to scale is closely related to the productivity of individual inputs, which is the question of how proportion increase in all inputs will affect total production. Now let us go to the evaluating returns to scale. Returns to scale of production system can vary over different levels of input usage. There are various ways to examine the returns to scale, and one of which is the iso-quant analysis, which can be used to examine the returns to scale for a two-input, single-output production system. Now, returns to scale can also be graphically examined. In this graph, the slope of a curve drawn from the origin up this production surface indicates whether the returns to scale are constant, increasing, or decreasing. A straight line production function indicates a constant return when then the slope of such a line from the origin is falling. It indicates a decreasing returns to scale. While if the slope of such a line from the origin is rising, the returns to scale is revealing an increasing returns. If decreasing returns to scale are present, total output grows slower than input use. When increasing returns to scale are present, total output grows faster than input use. Output elasticity and returns to scale, even though graphic representations of return to scale, such as the previous slide, are intuitively appealing, returns to scale can be accurately determined for any production function through the analysis of the output elasticities. Output elasticity is the percentage change in output associated with a 1% change in all inputs and a practical means for returns to scale estimation. Below is the equation for the output elasticity. It represents E sub Q equals the percentage change in output, or Q, represented by Q, over the percentage change in all input, represented by X. When X refers to the capital, labor, energy, and etc. Now this can be interpreted if percentage change in Q is greater than the percentage change in X, then E sub Q is greater than 1. Returns to scale are increasing. Percentage change in Q is equal to the percentage change in X, then the E sub Q is equal to 1. Returns to scale are constant. Percentage change in Q is less than the percentage change in X, then E sub Q is less than 1, which can be interpreted as that the returns to scale are decreasing. Now, returns to scale estimation in most instances can easily be estimated. For example, assume all inputs in the unspecified production function H sub HQ equals the function of the quantity of Kx, Ky, and Kz are increased by using the constant factor K, where H is the proportional increase in Q resulting from a k-fold increase in each input factor. Interpretation can then be if H is greater than K, then the percentage change in Q is greater than the percentage change in the inputs. Q is greater than 1, and the production function exhibits increasing returns to scale. If H is equal to K, then the percentage change in Q equals the percentage change in the inputs. Q is equal to 1, and the production function exhibits constant returns to scale. If H is less than K, then the percentage change in Q is less than the percentage change in the inputs. Q is less than 1, and the production function exhibits decreasing returns to scale.